It arrived without sound, without warning, and without allegiance to the Sunday. In the immensity of space, where stars scatter like grains across a boundless ocean, something moved against the quiet patterns that had endured for billions of years. Astronomers gave it a name 3, I divided by Atlas, but the name could not soften the strangeness of what it represented. It was a visitor from beyond, an interstellar fragment slipping through the solar system like a shadow through a temple. No comet's tail marked its passing, no planet's rhythm slowed its course. It did not belong, and it did not care to hide that fact. The first sighting was unremarkable, a dim glimmer nearly erased by the background of stars. Yet within hours, calculations revealed the impossible. This body was not bound to the Sunday. Its path was hyperbolic, a trajectory that declared exile from every orbit. It had come from beyond, and it would leave again, never to return. For those who gaze at the skies, the moment carried both triumph and unease. To discover such a thing was inevitable. To witness it firsthand was extraordinary, but to confront its silence was profoundly unsettling. The cosmos is vast, too vast for human language to hold. Interstellar space stretches like an endless desert where stars burn as distant campfires. That an object should cross between them is natural. Rocks and ice drift endlessly, shards of creation thrown outward by violent collisions, wandering for eons. But the details of 3, I divided by Atlas, unsettled in ways that could not be dismissed. It moved with a speed that exceeded the familiar. Its reflection confounded instruments, hinting at textures no one could fully explain, and the absence of a comet's gaseous veil made it stranger still. It came clothed in silence, without the ordinary signatures that comfort scientists with predictability. The unease deepened because this was not the first time. Memories of Oumuamua still lingered, the first interstellar visitor to pass through the solar system just years before. Oumuamua had startled the scientific community with its cigar-like shape, its acceleration unexplained by gravity alone, and its refusal to behave like a simple rock. Many had hoped that the second visitor might bring clarity. Instead, 3I divided by Atlas arrived as if to deepen the mystery, offering only more contradictions, more enigmas, more reasons to question the boundaries of knowledge. Fear, in science, does not roar like mythological monsters. It whispers in anomalies, in equations that refuse to settle into balance, in instruments that reveal the impossible. When the orbit of 3I, divided by Atlas, was traced backward into the abyss of interstellar space, the silence of its origin was deafening. Where had it come from? What forces had shaped it? Was it merely a shard of cosmic stone, or a fragment of something larger, stranger, and beyond imagination? The questions grew not from danger of collision, its path would never cross Earth, but from the threat of ignorance. The fear that the universe was not what it seemed, and that humanity's grasp of physics was less secure than it believed. For centuries, humankind has greeted the unknown with story. In the age of fire, the unknown became gods, beasts, and spirits. In the age of reason, it became equations, hypotheses, and data streams. Yet the feeling remains the same: awe entangled with dread, fascination braided with unease. To watch 3I divided by Atlas glide across the sky was to witness the embodiment of that duality. It was a reminder that the solar system is not a closed sanctuary, but a crossroads, a place where wanderers from unreachable distances may appear without notice. And so the tale begins, not of an object alone, but of humanity's encounter with a question it cannot yet answer. What is 3I divided by Atlas? Why does it move as it does? What secret does it carry from the interstellar night? The fear lies not in the rock itself, but in the silence that surrounds it. For silence in science is not emptiness, it is a riddle waiting to be solved. and a reminder of how fragile certainty truly island. The story of 3I divided by Atlas did not begin with drama. It began, as many cosmic discoveries do, with patient eyes searching the heavens for signs too faint to stir the imagination of the untrained. In the spring of 2020, the Atlas survey, short for the Asteroid Terrestrial Impact Last Alert System, swept its gaze across the night sky. This network of telescopes, stationed in Hawaii, was designed not for interstellar riddles but for planetary defense, to catch asteroids that might threaten Earth. Each night, its instruments recorded streams of light, tracking the countless small bodies that inhabit the solar system. Yet hidden within those lines of data lay something unexpected. The astronomers who worked with Atlas were familiar with routine discoveries. Small asteroids appear often. Faint comets occasionally wander into view, shedding the first wisps of vapor as they awaken under the Sunday. But this time, the object that appeared did not fit those molds. Its path curved oddly, slipping through predictions in ways that did not align with the gravitational choreography of planets and comets. In their data, it traced a line that stretched too far, bending around the Sun, not in an ellipse, but in a hyperbola. Such a path was no accident. Hyperbolic trajectories declare one thing with certainty: the object does not belong here. This was the third time such a visitor had been recognized. The first had been Oumuamua in 2017, the second Comet 2I divided by Borisov in 2019, and now 3I divided by Atlas. But where Borisov had looked like a typical comet, shedding gas and dust in a familiar display, 3I divided by Atlas was strangely muted. Its appearance did not match its expected behavior. Astronomers leaned closer to their instruments, recalculating, adjusting, and debating. In the records of history, the moment of discovery often carries romance. Galileo peering through his telescope, Herschel noticing a faint star that became Uranus, Hubble proving that galaxies lay beyond the Milky Way. But modern astronomy tells its stories in streams of digital images, long nights of cross-checking, and the collective hum of computers processing the sky. Within that unpoetic machinery, however, a profound revelation still waits to be found. For when the scientists realized what 3I divided by Atlas was, awe swept through their community. The solar system, so seemingly self-contained, had been pierced again by a messenger from afar. What were the astronomers studying when they found it? They were not looking for visitors from other stars. They were safeguarding Earth. The Atlas survey had been created after years of warnings about planetary defense, reminders that extinction could come not from war or plague, but from a stone falling from the void. Its mission was vigilance, and yet, in that vigilance, it caught something far stranger than any local threat. A fragment that had traveled perhaps millions of years between stars had slipped into its gaze. The names attached to the discovery may fade, but their work echoes with significance. They are part of a lineage of watchers, those who peer into darkness not knowing what they will find. Their triumph is quiet, their reward often uncertainty rather than clarity. For with 3I divided by Atlas, recognition brought not answers but questions. Where had it come from? How long had it wandered? What scars of ancient collisions did it carry on its hidden surface? In the moment of discovery, excitement mingled with unease. Each new calculation refined its path, and each refinement confirmed the truth. It was unbound. It had entered the sun's reach from one direction and would depart into another, indifferent to the pull of any planet. Unlike a comet, it bore no clear trace of life-giving water. Unlike an asteroid, it seemed to shimmer with strange reflective qualities. In its refusal to conform, it became something more than a discovery. It became a story, and that story was only beginning. When the first announcement spread beyond the tight circles of survey teams and orbital calculators, the scientific community paused. The discovery of 3I divided by Atlas was not unprecedented. Oumuamua and Borisov had prepared the ground, but each new interstellar visitor is a disruption, a tremor that shakes the quiet assumptions of astronomy. The echo of Oumuamua was immediate because the memory of that first enigma remained raw. Oumuamua, discovered in October 2017, had not behaved like anything in the catalogues. At first, astronomers thought it might be a comet, a shard of frozen material that would flare into brilliance as the sun's heat liberated its gases. Yet, Oumuamua showed no tail, no visible outgassing, no cloud of dust. Its light curve, the rhythm of its brightness as it tumbled, suggested a body oddly elongated, perhaps like a cigar, or, some argued, like a pancake stretched thin. Most unsettling of all, when its trajectory was mapped, it seemed to accelerate slightly, as if nudged by a force beyond gravity. Radiation pressure from the sun was one possibility, but not one that explained all the details. Some dared to whisper, could this be an artifact, a probe, a sail adrift between stars? That question lingered in the years after its departure, haunting conferences and filling scientific papers with speculation. And so, when 3I divided by Atlas appeared, the community leaned in, their anticipation sharpened by the hope of clarity. Would this second cousin confirm Oumuamua's mysteries or dispel them? Would it prove that the first enigma had been a strange accident, or would it deepen the wound of uncertainty? At first glance, 3I divided by Atlas seemed quieter, less dramatic. Its brightness did not fluctuate so wildly. It traced a path that could be calculated with steadier hands. But beneath that surface, peculiarities soon emerged. Its reflection was uneven, suggesting a complex structure. Its silence, no plume of cometary vapor, no predictable shedding of ice, reminded many of Oumuamua's stubborn refusal to behave. In both cases, the cosmos seemed to play a trick, presenting something familiar in outline but alien in detail. The echoes stirred unease, because two anomalies are harder to dismiss than one. With a single event, one can invoke chance, coincidence, a rare configuration. But with repetition, a pattern begins to form. If Oumuamua was strange, and Borisov was almost normal, and now Atlas carried new oddities, then perhaps interstellar space is not the realm of uniformity scientists once imagined. Perhaps it is a theatre of endless variety, where fragments of shattered worlds drift in forms that resist earthly categories. This is why scientists speak of paradigm shifts with caution. A single contradiction can be argued away. A second begins to demand a new language. The paradigm that comets and asteroids from other stars should resemble those within our system now wavered. What if interstellar travelers are consistently unclassifiable, shaped by physics and collisions in regions far beyond our knowledge? What if they are not accidents at all, but emissaries of processes we have yet to comprehend? In the shadow of Oumuamua, every new visitor is more than itself. It is a mirror, reflecting back the unresolved fears of science. 3I, divided by Atlas, carried that burden heavily. To some, it was another step toward cataloguing the diversity of interstellar debris. To others, it was the drumbeat of a deeper truth, that the solar system is porous, that the universe is restless, and that the familiar is but a fragile illusion. As astronomers whispered comparisons, journalists reached for more dramatic frames, invoking alien sails and hidden technologies. The scientists were more cautious, but even their restraint carried an undertone of fear, for the repetition of mystery is more unnerving than the mystery itself. Oumuamua had left too many questions in its wake. Now, with 3I divided by Atlas gliding through the sky, those questions had returned. sharper, heavier, demanding answers that science could not yet provide. When its orbit was calculated with precision, the truth emerged with undeniable clarity. 3I divided by Atlas was not bound to the Sunday. Its trajectory was hyperbolic, not elliptical. Unlike the planets, which dance in closed loops, or comets, which follow elongated ovals that bring them back after centuries, this traveler carried no intention of return. Its path was that of an exile, brushing against the light of the sun only once, before drifting outward again into the interstellar abyss. This realization gave astronomers both exhilaration and dread. Exhilaration, because it confirmed once more that our solar system is not a sealed vault, but a crossroads where fragments of other star systems may appear. Dread, because its unbound nature reminded them how little control humanity has over what passes through. The sun's gravity, so commanding over its family of planets and comets, could only bend the course of 3I divided by Atlas, not claim it. In the cosmic hierarchy, even the sun is powerless against a true outsider. Tracing its path backward, researchers sought its origin. Their calculations stretched the trajectory into the past, beyond the boundaries of known stars. Yet the trail dissolved quickly into uncertainty, because even a tiny error in measurement grows vast when projected across interstellar distances. Was it ejected from a young planetary system by a collision? Was it the remnant of a shattered moon, flung away during the birth of alien worlds? No answer could be proven, only imagined. Its home, like its destination, remained veiled. What made the unbound path particularly unsettling was its velocity. It raced through space at speeds exceeding anything native to the sun's kingdom. Comets and asteroids obey gravitational limits. They are born, contained, and sculpted by the system they inhabit. But an interstellar traveler arrives, carrying momentum from some ancient event, some distant catastrophe. It is a messenger not only of another place, but of another time, bearing the scars of a history that can no longer be witnessed. To imagine such a path is to confront immensity. For 3I divided by Atlas to reach us, it must have wandered across the void for millions, perhaps billions of years. In that silence, stars have been born and died. Galaxies have collided. Civilizations, if they exist elsewhere, may have risen and fallen. Yet this fragment continued, indifferent, carrying on its flight until the small lantern of the sun intercepted its journey. Humanity, brief as it is, happened to be watching at just the right moment. The strangeness lies not only in its trajectory, but in the reminder it delivers. The solar system, often pictured as a clockwork mechanism of orbits and cycles, is not immune to intrusion. Visitors from beyond will come, again and again, on paths that pay no heed to our definitions of inside and outside, safe and dangerous. 3I divided by Atlas is a proof, written in motion, that cosmic borders do not exist. This realization pressed heavily on those who studied it. A closed system can be mastered, catalogued, predicted. An open system, pierced by the unpredictable, demands humility. The fear was not of collision but of implication. What else drifts between the stars, unseen? What might enter next, unannounced? And what if one day the visitor is not harmless, but massive enough to alter the fate of worlds? As the unbound path of 3I divided by Atlas carried it deeper into the inner solar system, astronomers tracked it relentlessly. Every curve of its arc, every shift in its brightness, became data. Yet the data only confirmed the same truth over and over. This was no child of the Sunday. It was an alien in every sense of the word, not because of technology, not because of intention, but because of origin. Its presence was a reminder that the universe is not ours, and never was. As its path was charted with increasing precision, Another element emerged to trouble the scientists who watched it: velocity. The numbers that described 3i divided by Atlas were not ordinary. Objects born in the solar system obey predictable ranges of speed, their energy confined by the sun's grasp. But this visitor traveled with momentum that could not be accounted for by any local origin. Its velocity, measured against the stars, was too high, a silent declaration that it came from elsewhere. Speed, in cosmic terms, is a language of history. It tells of forces once applied, collisions endured, and slingshot encounters with stars and planets long vanished. For 3i divided by Atlas to enter the solar system at such a pace meant that somewhere in the deep past, some violent act had hurled it into exile. Perhaps it was a shard torn loose when planets collided in a distant system. Perhaps it was flung outward by the gravity of a giant star or cast away during the collapse of a protoplanetary disk. Whatever the cause, it had carried that momentum across uncounted light years until, by chance, it intersected our own small corner of the galaxy. To the scientists who studied it, the speed was both thrilling and unsettling. It confirmed its interstellar nature beyond doubt, but it also placed it in a category of objects that defied comfort. For if something so fast, so ancient, could arrive unannounced, what else might follow? If a fragment of rock or ice could wander between stars and appear suddenly near Earth, what protections did our species truly possess? The threat was not that 3i divided by Atlas would strike its path was clear of the planets, but that it revealed how vulnerable we are to the unknown. The velocity also challenged models of what such bodies should look like. At such speeds, surface ice should sublimate quickly, streaming away in visible tails. Yet 3i divided by Atlas remained largely silent, refusing to display the luminous plume of gas that would have reassured astronomers with familiarity. Instead, it seemed hardened, enigmatic, as though whatever history had propelled, it also stripped it of the signatures scientists expected to see. The absence of such evidence made its speed more haunting, as if it were not merely a rock but a cipher, carrying information we lacked the means to decode. In the halls of observatories, the discussions turned philosophical. Einstein's relativity had long explained how velocities accumulate, how time itself bends for objects that approach the limits of light. But 3i divided by Atlas forced another kind of reflection, not about physics alone, but about place. Humanity moves slowly, confined to one planet, one fragile biosphere. To confront an object traveling across the galaxy at such a relentless pace was to confront scale itself. Against its momentum, the Earth seemed small, the Sun seemed provincial, and human lifetimes seemed like sparks extinguished before the night could notice. This is why velocity unsettles. It is not merely a number in kilometers per second, it is a measure of our own immobility, our own stillness against the restless flow of the cosmos. 3i divided by Atlas did not pause, did not slow, did not yield to observation. It rushed onward, as if indifferent to the curiosity it ignited. Its pace was a message written without words. The universe does not wait. And so, the question deepened. Was its speed simply the echo of natural forces, or did it suggest something else, something that pushed it beyond the boundaries of chance? If Oumuamua had accelerated unexpectedly, and now 3i divided by Atlas moved with its own troubling vigor, then perhaps velocity itself was the mystery, not just the measure of motion, but the clue to forces still unknown, forces that might reshape our understanding of how the universe moves. As telescopes continued to trace its journey, scientists turned their attention not only to the speed of 3i divided by Atlas, but to the way it reflected light. Here the strangeness grew sharper. Many comets announce themselves with a shimmering veil. Sunlight heats their icy skin, gases escape, and the object is crowned with a halo and tail. But 3I divided by Atlas remained quiet. No plume rose, no stream of dust glittered in its wake. Instead, what emerged was a faint, irregular signature of reflection that puzzled every attempt at explanation. The brightness it showed was inconsistent with the surfaces astronomers knew well. It was neither the dark, carbon-rich dullness of asteroids, nor the bright, icy glare of a pristine comet. Its albedo, the fraction of light it reflected, fell into a grey region, hinting at unusual textures or materials. Some measurements suggested patches of varying reflectivity, as though the body was scarred, fractured, or sheathed in an uneven skin. In the data, it appeared almost as a riddle, cold, silent, yet strangely luminous in places where no gas or dust should have altered its face. This was the cold signature of 3I divided by Atlas, a paradoxical mixture of stillness and subtle shine. Instruments strained to resolve its spectrum, to pull from faint photons the secrets of its composition. But the results resisted easy classification. There were no clear markers of water vapor, no decisive spikes pointing to common molecules. The silence was scientific as much as visual. The spectrum spoke in incomplete sentences, half-formed words of a language no one could translate. The absence of outgassing raised deeper questions. Perhaps its ice had been burned away in countless passages near distant stars, leaving only a desiccated shell. Perhaps it was not icy at all, but rocky, metallic, or covered in exotic compounds, forged under conditions alien to our own system. Some speculated that interstellar radiation, endured over millions of years, might have scorched its skin into something wholly unfamiliar, a blackened armor that resisted both light and heat. Others entertained stranger possibilities. Could the irregular reflections indicate flat surfaces, perhaps unnatural in origin? Was it coincidence that the data suggested angular glints, like facets, rather than the rounded chaos of natural rock? Most dismissed such ideas as unlikely, yet the whisper persisted in conferences and late-night discussions. After all, Oumuamua had once provoked similar questions. And now, another visitor appeared to taunt the imagination with silence where activity should have been. The cold signature unsettled for another reason as well. Without the familiar plume of a comet, the ability to estimate its size and mass grew weaker. Astronomers had only its brightness, only the faint variations of light to infer its shape, and in those variations lay contradictions. Some readings suggested a body small and compact. Others implied a larger, flatter form. The lack of clarity became a kind of shadow, one that expanded the object's mystery rather than narrowing it. To gaze upon such a traveler, even indirectly through data, was to confront the possibility that the universe hides not just answers, but deliberate silences. Nature sometimes reveals itself with generosity, a comet blazing with detail, a planet circling with predictable rhythm. But sometimes it conceals, offering fragments so incomplete that every interpretation collapses into doubt. 3I divided by Atlas belonged to the latter. Its surface spoke in riddles, its silence hinted at strangeness, and its cold signature became another reason for unease. For the astronomers who measured it night after night, the experience was humbling. The object was no larger than a fragment of stone compared to the giants of the cosmos. Yet, in its refusal to conform, it became vast. Every anomaly widened the gulf between what was known and what was possible. And in that widening gulf, fear took root, not the fear of impact, but the fear of meaning. The pursuit of 3I divided by Atlas soon became a test of instruments as much as imagination. To study such a faint and fleeting visitor required the finest tools at humanity's disposal. NASA's network of telescopes, designed for vigilance and defense, bent their gaze toward it. The asteroid terrestrial impact last alert system, which had first glimpsed its passage, continued to track it relentlessly, sending coordinates to observatories worldwide. The Pan-STARRS survey in Hawaii added its data, refining the trajectory, mapping each point of light into an arc that confirmed its interstellar freedom. Other eyes joined the effort. The Hubble Space Telescope, still a sentinel of the heavens, turned its aging but precise instruments toward the object. Adaptive optics from ground-based observatories captured its flickering signal against the background of stars, and each measurement added to the puzzle rather than solving it. No matter how many photons were gathered, the light curve resisted simple explanation. Some nights suggested rotation, others a surface mottled with brightness and shadow, as if the object itself defied being held in one consistent model. To watch it was to strain at the edges of technology. Here was a fragment traveling through the inner system, yet so small and dim that even our best telescopes could not fully resolve it. Unlike planets or even large comets, which reveal themselves in photographs, 3I, divided by Atlas, remained a point of light, a whisper against cosmic noise. Only through mathematics, through careful plotting of brightness and orbit, could its reality be drawn. It was as if the universe had placed a veil over its features, allowing only suggestion to pass through. NASA's Deep Space Network, more accustomed to speaking with spacecraft across the solar system, listened for signals. None came. But the very act of listening revealed the seriousness with which scientists regarded the visitor. If an anomaly lingered, if a possibility of intelligence clung to its silence, then no precaution could be dismissed. The search for extraterrestrial intelligence, SETI, pointed antennas toward it as well, sweeping for even the faintest whisper of radio. Again, silence answered. Yet silence itself can unsettle. Instruments are built to confirm, to measure, to return clarity. But with 3I divided by Atlas, they returned ambiguity. Its faint glimmers contradicted each other. Its spectral signature dissolved into noise. Its behavior remained still where activity was expected. The telescope strained, the detectors gathered photons across nights and weeks, and still the visitor refused to yield identity. This is the paradox of scientific vigilance. The more carefully one looks, the sharper the outlines of mystery become. The very tools designed to conquer uncertainty can sometimes reveal only deeper layers of it. With each observation, the scientists hope to catch a glimpse of the ordinary, a tail, a cloud, a spectral fingerprint, but instead the strangeness thickened. The tools were working. It was the universe that refused to cooperate. Among the scientists, the mood was divided between exhilaration and unease. Exhilaration, because every new data point extended human knowledge, drew a finer sketch of a traveler from beyond. Unease, because the sketch refused to resemble anything familiar. The more NASA and its partners focused their vigilance, the more the object seemed to retreat into strangeness, as though its true nature was not merely hidden but actively elusive. And so the work continued, night after night, instruments straining, scientists debating, theories forming and dissolving. The vigilance of science was unwavering. But vigilance cannot erase the feeling that sometimes the universe watches back, offering puzzles instead of answers, and silence instead of certainty. 3I divided by Atlas remained that puzzle, an object both faint and immense, defined less by what it revealed than by what it refused to say. As weeks of observations accumulated, faint patterns began to emerge, yet with them came whispers of anomalies that deepened the enigma. In the data streams, 3I divided by Atlas flickered oddly, its brightness rising and falling in ways that hinted at rotation but never quite conformed to a stable rhythm. Astronomers are used to such light curves. Spinning asteroids brighten when reflective sides face Earth, then dim as darker regions turn away. But this visitor seemed to dance irregularly, as if its body were fractured or tumbling in a chaotic spin. The irregularities might have been explained by shape. Perhaps 3I divided by Atlas was not rounded like an asteroid, but jagged, asymmetrical, its surfaces glinting at unpredictable angles. Yet the variations suggested more than shape. They hinted at surfaces with strange reflectivity, patches that did not fit familiar categories of rock or ice. The whisper within the data was of something inconsistent, something that obeyed no simple model. Other anomalies surfaced in the spectral readings. The faint photons captured by instruments bore no strong chemical fingerprints. For comets, water vapor, carbon dioxide, or organic molecules usually speak clearly in spectral lines. For asteroids, silicates or metallic traces can be identified. But 3I divided by Atlas murmured in incomplete tones, yielding no decisive answer. It was neither clearly comet nor confidently asteroid. In the silence of its spectrum, astronomers sensed a refusal to belong to any known class. This silence, paradoxically, became loud in scientific circles. Each time the data resisted categorization, the mystery deepened. It was as though the object itself carried layers of concealment, each peeled back only to reveal another absence. "What is it?" became the recurring question, not shouted but whispered, as though the uncertainty itself demanded reverence. Some speculated that the anomalies might arise from its long interstellar journey. Radiation could have scorched its surface into new materials unknown in our solar system, leaving a skin that absorbed and reflected light in bizarre ways. Others suggested fragmentation, that 3I divided by Atlas might once have been larger, now reduced to a shattered remnant whose fractured faces caught light in chaotic patterns. And among the most cautious, a darker possibility hovered. What if the anomalies were not random, but intentional, shaped by design rather than accident? NASA's data analysts, accustomed to extracting clarity from faint signals, found themselves tracing uncertainties instead. The early anomalies became the whispers that would not leave, lingering in every conversation, every recalibration of orbit and brightness. To those who looked long enough, the mystery seemed not to weaken under study, but to grow stronger, as though the very act of scrutiny fed its strangeness. Science thrives on anomalies. They are the cracks where new knowledge enters. But anomalies also unsettle because they expose the limits of understanding. For 3I divided by Atlas, the whispers in the data were not loud enough to prove anything, yet too persistent to dismiss. They carried a weight that pressed against certainty, reminding every observer that the universe does not always reveal itself in categories or in comfort. And so, the anomaly became part of the story. Each whisper of irregularity transformed 3I divided by Atlas from a mere interstellar rock into a riddle that unsettled even the most disciplined minds. The universe had placed something in our skies that behaved almost like what we knew, but not quite, and in that not quite lay the deepest unease of all. The more carefully its path was studied, the more troubling the details became. Gravity, the lawgiver of the cosmos, should have dictated every curve of its motion. Objects falling toward the sun accelerate in precise patterns, their orbits written in equations that have endured since Newton and Einstein. Yet the orbit of 3I, divided by Atlas, did not sit comfortably within those expectations. At first, the discrepancies were subtle, tiny deviations between the predicted path and the observed one, small enough that some dismissed them as noise. The natural imprecision of instruments stretched to their limits. But as the data accumulated, the whispers grew louder. The curve of its trajectory suggested something more than gravity at work, as though the sun's pull were not the only hand guiding its flight. This riddle echoed a memory. Oumuamua, whose unexplained acceleration had sparked years of debate, could sunlight itself, pressing against a thin, sail-like structure, have nudged that earlier visitor? Could outgassing too faint to detect have given it a hidden push? Neither explanation satisfied fully, and now, in the quiet traces of 3, divided by Atlas, the same unease began to stir. Some argued that the object's shape, perhaps elongated, perhaps fragmented, might account for the anomalies. Others wondered if unseen jets of vapor, too weak for telescopes to resolve, could still push it subtly. Yet the absence of any visible cometary activity made this explanation fragile. What force, then, was at play? The fear in equations arises when the universe refuses to balance. Each mismatch between prediction and observation is a fracture, a reminder that the laws we believe complete may only be partial. And in those fractures, doubt seeps in. Perhaps it was nothing extraordinary, only the combined effect of factors not yet measured. Or perhaps it was something more profound, a clue to forces unrecognized, a sign that the universe still holds secrets beyond even Einstein's reach. For the scientists, the gravity riddle was not about danger, but about meaning. If the laws that govern planets and stars cannot fully describe a small visitor, then the gap may point towards something larger, something woven into the fabric of space itself. A new force? A hidden interaction? Or evidence of a history so alien that no earthborn model could capture it? The riddle carried unease because gravity is supposed to be universal. It binds galaxies, sculpts black holes, and writes the clockwork of the solar system. To find even a hint of deviation was to confront the possibility that the universal is not absolute, that exceptions drift between the stars. 3, divided by Atlas, glided on, silent, indifferent to the theories spun around it. Each night of observation confirmed its freedom, each calculation reaffirmed its strangeness. The gravity riddle remained, unresolved, like a shadow on the equations. And shadows, in science, are often the first sign that something immense lies just beyond the light. The deeper astronomers pressed into the faint signals of 3 divided by Atlas, the more they encountered something profoundly unsettling spectral echoes that did not fit neatly into the established categories of cosmic matter. Normally, when light from the sun bounces off an object, it carries with it a chemical signature. Spectroscopy can reveal water vapor, frozen carbon dioxide, silicates, organic molecules, or metals. Each leaves a distinct fingerprint, a rhythm etched into the spectrum that allows scientists to say, this is ice, this is stone, this is dust. But when they turned these same techniques on 3, divided by Atlas, the answers dissolved. The lines were weak, inconsistent, sometimes vanishing altogether. Observers saw glimmers of compounds, then lost them in noise. Reflections suggested mixtures too complex to pass, or perhaps something entirely unfamiliar. To describe its chemistry was to describe a ghost, a form more absence than presence. Even more curious were moments when the object appeared to reflect light at angles sharper than expected. Rather than diffusing like a rough surface, it sometimes gleamed in a way that suggested flatness, like facets catching the sunday. The idea was not confirmed, yet it lingered. What if some of its surfaces were unusually smooth, unnatural in their reflection? Most dismissed the speculation, but the phrase "unnatural echoes" slipped quietly into discussions. Here lies the most dangerous space in science, where anomalies brush against imagination. Some proposed that exotic processes in the deep interstellar medium might explain the mystery that cosmic rays, over millions of years, had restructured its surface, baking it into materials rare or unknown within our system. Others wondered if the odd reflections were the scars of catastrophic collisions, fractures glinting like broken glass, but the data refused to settle. It was then that whispers of something more extraordinary began to circulate, not in official papers, but in the cautious language of late-night conversations. Could such echoes hint at design rather than accident? Could the glints resemble panels, sails, or engineered layers? The suggestion was rarely spoken aloud in public, for fear of ridicule. Yet privately, some admitted the thought had crossed their minds. The silence of the spectrum, combined with those fleeting gleams, invited questions too large to ignore. Science thrives on skepticism, and most scientists pushed back against such speculation. They pointed to data gaps, to instrument error, to the dangers of human pattern seeking. They reminded colleagues of Oumuamua when similar theories had surged and divided the community. But the very need to push back revealed how unsettling the possibility was. An ordinary comet would have silenced such talk with its tail. An ordinary asteroid would have produced clear mineral fingerprints. 3I divided by Atlas did neither. The unnatural echoes remained just that. Faint, ambiguous, impossible to confirm. Yet they haunted every attempt to interpret the object. The universe, it seemed, had placed a mirror before humanity, reflecting not only photons, but fears, hopes, and the restless question of whether we are truly alone. Numbers should comfort, equations should close like doors, bringing order to chaos. Yet with 3I divided by Atlas, the mathematics bred unease. Each attempt to model its trajectory, its light curve, its composition seemed to slip, leaving a residue of uncertainty. For scientists trained to find harmony in the laws of motion, this dissonance was disquieting. The fear was not of impact; the object posed no danger to Earth. The fear arose in the equations themselves. Here was an intruder that seemed to obey the great laws of gravity and motion, and yet not entirely. Small inconsistencies, subtle mismatches, unresolved accelerations, all of them gnawed at confidence. They hinted at missing pieces, hidden variables, forces unaccounted for. In astrophysics, fear does not wear the face of monsters. It emerges when the tools of reason falter, when Newton's clarity or Einstein's relativity prove insufficient to contain what is observed. The abyss of the unknown cracks open. That abyss haunted the scientists who studied 3I divided by Atlas. Was it simply an irregular shard, its strangeness an illusion born of poor data? Or was it something larger, a messenger, revealing that our understanding of physics is incomplete? The unsettling echoes grew louder when compared with its predecessors. Oumuamua had accelerated in ways unexplained by visible forces. Borisov had resembled a comet, but even it bore subtle oddities. And now, 3I divided by Atlas moved with quiet refusal to fit any category. 3 visitors, 3 anomalies, coincidence strained credulity. What pattern was forming? For some, the fear lay in what might be discovered if the pattern were pursued. What if these visitors were not debris at all, but something more deliberate? What if the small discrepancies in velocity or light were not natural, but engineered? To voice this was to risk dismissal. Yet in the solitude of their thoughts, some scientists felt the weight of the possibility pressing heavily. Others feared something deeper, that the anomalies pointed not to intention, but to forces woven into the fabric of the universe itself. Could there be subtle interactions between matter and the quantum vacuum that manifest only in such wandering fragments? Could dark energy, the mysterious agent accelerating the expansion of the cosmos, be playing a role at scales not yet recognized? If so, then 3I divided by Atlas was not merely a curiosity but a crack in the edifice of physics. Fear in equations is not loud. It is quiet, persistent, like a note held too long in the background of a symphony. It unsettles, not because it screams, but because it will not fade. That is what 3I divided by Atlas became. A reminder that the universe does not bend fully to our will, that our laws may only be approximations, fragile nets thrown across an ocean too vast to contain. As the object drifted outward on its unbound arc, the numbers followed and the fear remained. For scientists, certainty is a form of safety. To lose it is to glimpse the abyss, and 3I divided by Atlas was nothing if not an abyss carved into the heart of their equations. Speculation is a dangerous current in science. It begins as a quiet thought, a whisper born in the space between data points. But when anomalies persist, when equations resist closure, that whisper grows louder. With 3I divided by Atlas, some of those whispers carried the shadow of intelligence. The thought was not new. In 2017, Oumuamua had sparked similar conjecture. Its strange acceleration, its unusual shape, its silence where activity should have been all of these, had led some to wonder whether it was not a natural body at all, but a relic of technology. One paper, cautious yet daring, had suggested it could be a light sail, a thin structure propelled by starlight, perhaps the discarded probe of an ancient civilization. Most scientists rejected the idea, preferring natural explanations, yet the possibility had lodged itself in the imagination of the public and even in the private doubts of some astronomers. With 3I divided by Atlas, those doubts returned. Its reflective anomalies, its irregular tumbling, its refusal to display a comet's familiar behavior, these details stirred the same questions. Could it be artificial? Could it be an artifact drifting for millennia, long abandoned, crossing our system by chance? If so, was it a probe meant to watch, or merely debris left behind by unknown makers? NASA itself did not endorse such ideas, yet individual voices within the scientific community could not dismiss them entirely. The search for extraterrestrial intelligence turned its radio dishes toward the object, straining for even the faintest signal. None came. Still, the silence did not settle the matter. After all, what if the object was not transmitting? What if it had been adrift for millions of years, its purpose long since ended, its makers long since gone? The fear of intelligence was not only about aliens, it was about reflection, about what it would mean if humanity were not alone, if the universe were seeded with other minds capable of shaping matter and sending fragments into the stars. Such a realization would not only expand the cosmos, it would diminish the human sense of uniqueness, of centrality. To discover intelligence in 3I divided by Atlas would be to discover a mirror in the dark, one that reflects both our smallness and our potential future. The language of speculation remained careful. Unusual reflectivity, possible artificiality, low probability hypotheses. But behind the words, the unease was real, because to dismiss the idea entirely felt premature, and to embrace it felt reckless. The middle ground uncertainty was where most scientists remained, yet in that uncertainty, imagination thrived. In the end, 3I divided by Atlas gave no clear sign of being anything but natural, but the shadow of intelligence hung over its study like a ghost, not because proof existed, but because its absence of proof left the door open, and sometimes an open door is more frightening than a closed one. As the data on 3I divided by Atlas deepened, scientists could not help but recall its enigmatic predecessor. Oumuamua had left wounds in certainty, questions still raw and unresolved. The comparison was inevitable, and in that comparison, the sense of unease only grew. If Oumuamua had been strange, then 3I divided by Atlas was its phantom twin, different in detail, yet similar in defiance of expectation. Oumuamua's legacy lingered like a half-remembered dream. It had tumbled through the solar system without a comet's halo, had accelerated without visible cause, had flashed light curves that suggested unnatural elongation. Debate still raged about its true nature, an icy fragment shedding invisible hydrogen, a shard of nitrogen ice from a shattered exoplanet, or, more provocatively, a relic of technology adrift. Its departure had left only speculation, no clarity. And then came 3I divided by Atlas. At first glance, it did not mimic Oumuamua exactly. Its brightness was steadier, its path less riddled with unexplained accelerations. Yet the similarities haunted the discussion. Both were hyperbolic, both were silent where activity should have spoken, both carried spectral signatures that dissolved into ambiguity. Two objects, separated by years, each refusing to be comfortably named. Borisov, the second interstellar visitor, had seemed reassuringly ordinary, a comet with a glowing tail, behaving as comets should. But now, sandwiched between Oumuamua and 3I, divided by Atlas, it appeared almost like an exception rather than the rule. If 2 out of 3 visitors were anomalous, then perhaps the anomaly was not an accident but a pattern. The phantom twin comparison spread quietly in papers and conversations. 3I divided by Atlas was not a replica of Oumuamua, yet it seemed to carry its ghost. Every irregular flicker of light, every silence in its spectrum, echoed the earlier enigma. It was as though the cosmos had chosen to replay the same unsettling theme, not in repetition but in variation, like a composer weaving familiar notes into a new, darker movement. Scientists wrestled with the implications. Was the similarity evidence of a broader class of interstellar objects, unknown until now? Were such bodies more common than imagined shards of alien worlds that carry properties unfamiliar to our solar system? Or was it coincidence, 2 rare visitors arriving in succession, their strangeness magnified only by proximity in time? For the public, the connection was irresistible. Headlines invoked Oumuamua as soon as 3I divided by Atlas appeared. The idea of a twin, another alien messenger, another riddle from the stars captured imagination. NASA urged caution, insisting that speculation should not outpace data. But within the scientific community, even caution could not erase the shiver of recognition. To see 3I divided by Atlas was to see Oumuamua again, reflected in a distorted mirror. The phantom twin did not explain the first enigma, it only doubled it, made it harder to dismiss, harder to ignore. In that doubling lay the fear that we are not confronting an isolated puzzle, but the first notes of a larger, more unsettling symphony of mysteries drifting into our skies. By now, the catalogue of anomalies surrounding 3I divided by Atlas had grown long enough that natural explanations strained against their limits. Theories multiplied, each one attempting to thread the fragments of data into coherence, yet none fit without seams. The conversation began to swell into turbulence, mathematical turbulence, conceptual turbulence, where the great frameworks of modern physics were invoked to anchor what seemed otherwise unmoored. Einstein's general relativity stood first among these. Gravity, in its elegance, should have described the object's motion completely, and yet small mismatches lingered, deviations that clung to the orbit like shadows. Was it possible, some asked quietly, that such visitors revealed subtleties in space-time itself, subtleties our equations only approximate? If so, 3I divided by Atlas was not simply an interstellar stone, it was a probe of relativity's limits, a test particle wandering from places where the geometry of space might differ. Quantum theories soon joined the discussion. At the smallest scales, the vacuum itself seethes with fluctuations, fields shimmering with ghostly particles that appear and vanish. Could long interstellar journeys through such restless fabric alter matter in ways unseen in our calmer solar system? Perhaps the surface of 3I divided by Atlas was a record of those quantum seas, a texture sculpted by forces we have yet to measure. Some scientists reached further still, invoking cosmic inflation, the blistering expansion thought to have marked the universe's first moments. If fragments like this had drifted since epochs near creation, could their properties carry imprints of that ancient violence? To entertain the thought was to imagine 3I divided by Atlas as not just a traveler from another star system, but as a shard carrying whispers from the dawn of time. The turbulence of theory reflected a deeper truth. Every framework of physics is both map and prison. Relativity explains gravity until it doesn't. Quantum theory describes particles until they slip away. Between them lies a chasm where dark matter and dark energy lurk, phenomena known by their effects but invisible in substance. Could 3I divided by Atlas, by accident, have crossed into that chasm, carrying hints of forces we name but do not understand? Debates raged in conference calls and journal drafts. One camp insisted that natural processes must suffice: erosion, radiation, fragmentation, coincidences of geometry. Another camp, quieter but insistent, pointed to the persistence of anomalies as signs of something deeper. Theories collided like particles in a collider, each releasing sparks but no lasting synthesis. This turbulence was not failure but necessity. In science, contradictions are the crucible of progress, and 3I divided by Atlas, silent and indifferent, had become such a crucible. By refusing to conform, it drew Einstein's gravity, quantum fields, and cosmological inflation into the same conversation, reminding physicists how far they are from the dream of a unified theory. Yet behind the mathematics lingered a more unsettling thought. Perhaps the object was not anomalous at all. Perhaps it was the universe itself that is stranger than the models we write. In that case, 3I divided by Atlas was not the exception but the rule, and it was our expectations that were the anomaly. Among the swirl of explanations proposed for 3I divided by Atlas, one hypothesis grew louder, though it was as unsettling as it was elegant. Perhaps the object's strangeness was tied to dark energy. The very phrase carries unease. Dark energy is not a substance we can hold or detect directly. It is an inference, a ghost built into our equations to explain why the universe is not slowing in its expansion, but accelerating. It accounts for nearly 70% of the cosmos, and yet it remains invisible, undetectable, except by its vast effect. To invoke dark energy in the context of a single wandering fragment was bold. And yet, for some theorists, the leap was not impossible. If dark energy is woven into the fabric of space itself, might it not sculpt the behavior of objects moving across interstellar distances? Could 3I divided by Atlas, after millions of years adrift, bear subtle scars of that influence, accelerations too faint to match Newton's predictions, reflections too alien to match our catalogues of minerals? The possibility unsettled because it shifted the mystery from the object itself to the cosmos surrounding it. If 3I divided by Atlas was being shaped by dark energy, then every star, every planet, every particle of dust was equally ensnared. Its strangeness would not be unique but universal, a reminder that we live in a universe governed by forces we cannot see. Theories flourished. Some imagined that interstellar fragments might act as natural detectors of dark energy, their motions deviating in ways that could reveal its hidden properties. Others speculated more wildly, suggesting that certain anomalies might be evidence of local fluctuations in the cosmic field, regions where the expansion of space itself is uneven. If true, 3I divided by Atlas would not merely be a rock from another star system, it would be a messenger carrying news of the very fabric of reality. Yet there was another edge to this speculation, one far more unsettling. If dark energy truly dominates the universe, then it shapes not only motion, but destiny. It will drive galaxies apart, silence stars, and stretch space-time until everything familiar dissolves. To see its hand in the peculiar journey of 3I, divided by Atlas, was to glimpse that distant future, written in miniature in the path of a single stone. For most astronomers, the connection to dark energy remained tenuous, unproven, but the fact that it was discussed at all revealed how deeply 3I divided by Atlas had unsettled the field. An ordinary comet or asteroid would never have drawn such speculation. Only something that refused classification, something that whispered of the impossible, could force scientists to consider whether the greatest mystery of cosmology might be inscribed in a fleeting visitor. Thus, the object became more than itself. It was no longer only a fragment of matter. It was a lens through which humanity glimpsed its ignorance, a shard of interstellar silence that invited thoughts of expansion, decay, and the invisible engine driving the cosmos apart. The lure of dark energy was not that it explained 3I divided by Atlas, but that it reminded us how much lies beyond explanation. From dark energy, the speculation expanded further still, into realms even less tangible. Some physicists began to wonder whether 3I divided by Atlas could be not merely a traveler from another star system, but something stranger, a shard from another cosmos entirely. The idea was audacious, almost heretical, yet it emerged naturally in the turbulence of unanswered questions. The multiverse theory had long hovered at the edge of scientific imagination. Inflationary cosmology, which describes the universe's first moments as an eruption of exponential expansion, predicts that our universe may not be alone. If inflation can happen once, it might happen endlessly, bubbling new universes from the quantum vacuum like foam upon an ocean. Each bubble would be a cosmos unto itself, with its own laws, constants, and fates. And if so, then what separates them may not be impenetrable walls, but fragile boundaries where the fabric of one universe can brush against another. Could 3I divided by Atlas, some dared to ask, be evidence of such a crossing? Could it be a fragment expelled during a collision of cosmic bubbles, flung across a boundary invisible to us? Its anomalous trajectory, its refusal to match the behavior of known comets or asteroids, its spectral silence, were these not the very fingerprints one might expect from matter born under laws slightly different from our own? The suggestion was not embraced by all. To many, it was far too speculative, a poetic flourish more than a scientific argument. But even skeptics acknowledged the haunting logic. If our universe is one of many, then somewhere, sometime, crossings must occur. And when they do, fragments may wander between realms, carrying within them the chemistry of alien physics. For those who allowed themselves to imagine, the thought was staggering. If 3I divided by Atlas truly hailed from another cosmos, then its presence was a message not of aliens or technology, but of existence itself, that reality is larger than we can conceive, that the laws of physics we hold sacred are but local customs in a vast multiversal archipelago. Its silence, then, was not refusal but testimony, a mute declaration that we are not only not alone in space, but not alone in reality. This multiverse mirror interpretation remained at the fringes, more philosophy than physics. Yet it carried weight because the anomalies demanded something bold. To explain away every irregularity as coincidence seemed unsatisfying. To invoke the multiverse was terrifying in its grandeur. Between those poles, 3I divided by Atlas drifted, neither confirming nor denying, leaving only the echo of possibility. In this way, the object became not merely an astronomical curiosity, but a metaphysical provocation. It forced scientists to confront the scale of their ignorance, that perhaps what they studied was not just a body of rock and ice, but a fragment carrying the whisper of another universe, a mirror held up to our own. If the notion of the multiverse felt vast and dizzying, another hypothesis carried a sharper, more immediate edge of dread: the false vacuum. To physicists, this is no poetic phrase, but a mathematical possibility that lurks in the equations of quantum field theory. It suggests that the universe we inhabit may not be resting in its ultimate state of stability. Instead, it could be perched precariously in a false vacuum, an energy minimum that feels stable but is not. A deeper, truer vacuum might exist, and if ever triggered, it would unravel everything we know in an instant. The fear of false vacuum decay is not fantasy. It emerges naturally from the mathematics of particle physics, from calculations of the Higgs field that permeates space itself. If the Higgs potential lies in a false minimum, then all of reality exists on borrowed time. A fluctuation, a high-energy event, or an improbable quantum tunneling could someday spark a collapse. A bubble of true vacuum would form, expanding at the speed of light, rewriting the laws of physics as it devours the universe. There would be no warning, no defense, no survival. It was in the shadow of this terrifying idea that some dared to connect 3I divided by Atlas. What if its anomalous behavior, its irregular path and spectral silence were not simply quirks of composition? What if, instead, it bore evidence of a different vacuum state matter shaped under rules just slightly different from ours? Could it be a fragment flung from a region of space where the vacuum had already shifted, carrying with it the marks of altered physics? This speculation was almost unbearable, for it transformed 3I divided by Atlas from a curiosity into a harbinger. If it truly carried evidence of false vacuum decay, then its arrival was not merely a visit, but a warning that our universe is less stable than we imagine, that one day, perhaps without notice, the same fate could reach us. Most scientists resisted this line of thought, for good reason. There was no evidence, only conjecture. To tie an interstellar rock to the death of all things was a leap too far for cautious minds. And yet, the fear persisted not because of proof, but because of plausibility. False vacuum decay remains a recognized possibility in physics, even if remote. And 3I divided by Atlas, with its refusal to conform, provided fertile ground for such fears to take root. In the quiet of observatories, the thought was whispered, never declared. What if this is the sign? What if, in watching 3I divided by Atlas drift past our sun, we are glimpsing the first shard of a larger catastrophe unfolding elsewhere in the cosmos? Not an asteroid, not a comet, but a messenger from a region where the laws of physics themselves had collapsed. Even if unlikely, the idea had power. It reminded humanity of its fragility, of how small its certainties truly are. For if the false vacuum theory is true, then all that we know, atoms, stars, galaxies, life exists in a precarious balance, one that could dissolve without a trace. And 3I divided by Atlas, silent and unyielding, became the symbol of that precariousness. A fragment drifting in from the edge of existence, carrying with it the possibility that reality itself is not secure. Silence can be more unsettling than sound. When 3I divided by Atlas was first confirmed as an interstellar visitor, one of the immediate questions was whether it might be transmitting anything an echo of intelligence carried on waves invisible to the eye. If its anomalous features hinted at something beyond the ordinary, then perhaps the ultimate test was to listen. The search for extraterrestrial intelligence, SETI, responded quickly. Radio dishes turned toward the faint patch of sky where the object moved, sweeping across frequencies in search of a signal. The expectation was low. Interstellar visitors are, by every known measure, lifeless shards. But the strangeness of Oumuamua had already seeded caution, and 3I divided by Atlas carried enough echoes of its predecessor to warrant vigilance. For nights on end, dishes listened, passing the static for any rhythm, any whisper of intent. Nothing came. No narrowband transmissions, no pulses of artificial precision, only silence. Yet silence is not the same as certainty. A probe could remain dormant, long since abandoned, or designed in ways we do not understand. A structure drifting for millions of years might no longer function at all. And so, while the silence was noted, it could not close the question. It left a shadow of possibility hanging, a question suspended rather than answered. Optical searches followed, scanning for flashes of light, laser bursts, or reflective glints that might indicate controlled communication. Again, nothing. The silence grew heavier, its weight not in what was heard, but in what was not. Natural objects speak clearly. Comets with their tails, asteroids with their mineral signatures. 3I divided by Atlas spoke in fragments and then withheld the rest. This refusal to speak became itself a form of voice. In scientific circles, the phrase "signals in silence" began to circulate not as proof of technology, but as a reminder of how absence can provoke as much speculation as presence. The lack of ordinary cometry or asteroidal markers made the silence feel deliberate, even if it was not. Why would a natural body remain so mute? Why would its spectrum dissolve into ambiguity, its behavior slip through prediction, its composition refuse to declare itself? Of course, the rational answer was chance. Interstellar space is vast, and its debris may come in forms unfamiliar, altered by radiation, collisions, and time. Not every puzzle demands intelligence behind it. And yet, for those listening in the dark, the possibility could not be erased. What if the silence was intentional? What if it was not absence but restraint? The emotional weight of these questions was as heavy as the scientific ones. Humanity has long wondered whether it is alone. Each anomaly invites that longing to the surface. And when instruments strain for a signal and find none, they leave behind a void that imagination eagerly fills. 3I, divided by Atlas, offered exactly such a void, a silence deep enough to echo with both fear and wonder. In the end, the silence did not resolve the enigma, it deepened it. For silence, in the context of mystery, is never empty. It is a mirror, reflecting not what is there, but what we fear or hope might be. If silence was unsettling, the relentless watching of 3I divided by Atlas became a kind of obsession. Every instrument capable of turning toward it did so, for the object would not linger. Its trajectory guaranteed only a brief window of observation before it slipped back into the abyss. Hubble, nearing the twilight of its service yet still sharp-eyed, was directed toward the visitor. Against the faint glow of stars, the telescope recorded its glimmers barely more than points of light, but precious for their rarity. At the same time, ground-based observatories across the globe contributed their vigilance. From Chile's Atacama Desert, where the air is thin and clear, to the peaks of Hawaii, where telescopes sweep the Pacific sky, scientists gathered every photon they could. These were combined with data from Pan-STARRS and Atlas, refining trajectory, brightness, and rotation models. Even so, the object resisted clarity. Its light curve flickered with contradictions, refusing to settle into the stable rhythm of a known body. And then came the gaze of the James Webb Space Telescope. Though designed to peer into the earliest galaxies and the atmospheres of distant exoplanets, Webb was persuaded to turn its golden mirrors upon this closer enigma. With infrared precision, It sought signatures invisible to optical instruments. Yet once again, the results were ambiguous. Webb's data hinted at materials difficult to classify, spectral lines too faint or too irregular to place neatly in the catalogue of known substances. It was as if 3I divided by Atlas spoke a dialect of matter unfamiliar to our system. The pursuit extended beyond telescopes. Deep survey arrays mapped its movement across the sky, searching for variations invisible to the naked eye. Radio observatories continued to listen, though no whispers came. The combined effort represented a rare unity of science, a global network of eyes and ears straining to catch a fragment that would soon be gone forever. But what they captured was not clarity, but further enigma. Every tool sharpened the outline of mystery, not its resolution. The object seemed to glide just beyond comprehension, offering hints of explanation only to retreat again into silence. For the scientists, the experience was humbling. Here was a visitor, no larger than a mountain, perhaps smaller, and yet it withstood the collective might of Earth's greatest instruments. Some took comfort in this failure, seeing in it a reminder of the universe's vastness, its inexhaustible supply of questions. Others felt frustration, even fear, for if so much effort yielded so little, what if the cosmos held not just one mystery, but countless others slipping through our grasp unnoticed? In the end, the vigilance of Hubble, Webb, and the global array of observatories was not wasted. They had captured the traces of a traveler from the stars. Yet the traces were like footprints in shifting sand, suggestive but incomplete. And as 3I divided by Atlas drifted outward, beyond the reach of even Webb's mirrors, humanity was left with records that illuminated nothing so much as the stubborn silence of the unknown. While telescopes traced the faint light of 3I divided by Atlas across the heavens, another community of scientists turned to a different set of tools. Particle physicists, accustomed to probing the smallest scales of reality, began to wonder whether the anomalies of this interstellar traveler could be modeled not by astronomy alone, but by the physics of collisions and fields. For in laboratories like CERN, the universe itself is recreated in miniature, particles smashed together at energies that echo the first instance of creation. Could the secrets of 3I divided by Atlas be glimpsed in those collisions? The thought seemed distant, yet the parallels grew unavoidable. Its irregular acceleration, its spectral silence, its refusal to display familiar cometary behavior, these could be the scars of matter formed under conditions far removed from the solar system. If its atoms bore unusual structures, if its surface was altered by processes unknown to us, then only the language of particle physics might approach an explanation. Some theorists modeled it as a fragment of exotic matter, perhaps containing ratios of heavy elements different from those found here, forged in the collapse of a distant supernova or the merger of neutron stars. Others considered the possibility that its behavior reflected interactions with the quantum vacuum itself, subtle pushes and pulls that do not manifest in ordinary bodies bound by the sun's gravity. In these discussions, particle accelerators became the laboratories of speculation. If such anomalies could be recreated in controlled collisions, then the silence of 3I divided by Atlas might find a voice. Colliders also suggested darker possibilities. Could the object's strange acceleration be explained by an internal store of volatile compounds, substances not common in our system but familiar elsewhere? If so, it was not just a stone but a vessel, carrying chemistry alien to Earth. And if those compounds ever met the conditions to release their energy, the result might mimic the sudden outbursts seen in comets or something entirely unfamiliar. The idea of collisions took on another meaning as well. What if 3I divided by Atlas itself was the product of a catastrophic impact? A shard torn from a young planet in a distant system, flung outward with unimaginable violence, wandering across the galaxy until it stumbled into our skies. Its fractured light, its strange glints, could then be the testimony of that ancient violence, a remnant of a world we will never see. To frame it in the language of colliders was to confront scale itself. In Geneva, beams of protons smash together at nearly the speed of light, revealing particles too fleeting to exist in nature. In the cosmos, stars explode, planets collide, and matter is hurled across interstellar gulfs with energies no machine could replicate. 3I divided by Atlas was a bridge between those scales, a particle on the stage of astronomy, carrying within it the possibility of physics written in unfamiliar ink. And yet, as models multiplied, none provided certainty. The silence of the object remained, indifferent to speculation. Particle physics could offer metaphors, even frameworks, but the object itself resisted proof. It was as though the universe had given scientists a riddle too large for their colliders, too fleeting for their telescopes. Still, the effort was not in vain. In chasing the anomalies of 3I divided by Atlas, science pushed outward, connecting the vast with the minute, the celestial with the quantum. And in those connections lay the reminder that the universe is one fabric, stitched across scales, from the collisions of particles to the collisions of worlds. As the weeks of observation turned into months, a sobering realization settled over the community. Certainty was slipping away. For all the vigilance, for all the instruments trained on 3I divided by Atlas, the picture remained fractured. The object had passed closest to the sun, had swung through the inner system, and was now retreating outward, fainter with each night. Data continued to flow, but the clarity scientists had hoped for never arrived. This was the boundary of certainty, the point at which measurement blurs into speculation. Astronomy is a science of distance and faintness. It often builds truth from fragments, but with 3I divided by Atlas, the fragments were too few, too contradictory. The light curve suggested a body spinning, yet no stable rotation could be fixed. The spectrum hinted at minerals and compounds, yet dissolved before any could be confirmed. The trajectory exposed subtle deviations, but none conclusive enough to rewrite the laws of motion. Here, at the edge of knowledge, humility grows. To admit uncertainty is not weakness, but strength. And yet, it is unsettling. Scientists are trained to pursue closure, to extract signal from noise. When the noise remains, when the signal slips away, it feels like a personal failure, even though it is the cosmos itself withholding its truth. In conferences and papers, the language grew cautious. Possibly, likely, tentatively filled the pages. Models proliferated: cometary remnant, asteroid fragment, exotic ice, engineered sail, shard of another cosmos. Each carried arguments, each carried flaws. No single theory could gather all the evidence into harmony. And so, 3I divided by Atlas joined a small family of mysteries that science cannot yet explain, perhaps may never explain. Its strangeness was undeniable, its refusal to conform evident. But in the absence of decisive data, certainty dissolved into probability, and probability into possibility. What remained was not knowledge but ambiguity, a reminder that the universe resists being fully known. The boundary of certainty is not empty, however. It is fertile ground. From Oumuamua to Borisov to 3I divided by Atlas, anomalies have forced science to expand its questions, to connect cosmology with particle physics, to imagine futures where interstellar debris is not rare but common. The object may slip away, its mysteries unresolved, but the questions it leaves behind will continue to shape inquiry for decades. And perhaps that is its gift. To confront the limits of certainty is to confront the essence of science itself, not the possession of answers, but the pursuit of them. 3I divided by Atlas, in refusing to reveal its nature, has left humanity with something greater than knowledge, the reminder that the cosmos is vast, inexhaustible, and always beyond reach. When certainty falters, philosophy often enters. The mystery of 3I divided by Atlas was not only a matter of telescopes and equations, but also of meaning. In its silence, its anomalies, its refusal to be defined, it began to stir the oldest questions about reality, about human smallness, about the relationship between knowledge and wonder. Scientists are trained to resist philosophy, to cling to data, yet the greatest minds have always bridged both. Stephen Hawking, in his writings, often reminded us that the unknown is not a void but a frontier. He warned that the laws of physics, as we understand them, may be temporary scaffolds, provisional truths awaiting collapse. Carl Sagan, decades before, spoke of interstellar travel and the pale fragility of Earth, urging us to find humility in the immensity. Both voices echoed in the conversations around 3I divided by Atlas. Here was an object that exposed our ignorance, forcing reflection not only on physics but on existence itself. Some philosophers of science argued that the anomaly was a lesson in epistemology, the study of knowledge itself. Why do we seek certainty so fervently? Why is ambiguity intolerable? In a universe defined by vastness, perhaps the expectation of complete explanation is itself arrogance. 3I divided by Atlas reminded humanity that some questions may remain unanswered, and that awe is not diminished by ignorance, but sharpened by it. Others saw in the visitor a mirror of myth. Ancient cultures once watched the skies with stories in their hearts. A wandering star might be an omen, a god's messenger, a harbinger of change. Modern science strips away those myths, replacing them with mathematics. Yet when confronted with a fragment from beyond the stars, the old instinct returned. Was this object a sign, a reminder, a reflection of how small our certainties truly are? In this sense, 3I divided by Atlas became more than a physical body. It became a philosophical provocation. It asked whether reality is a closed book waiting to be read in full, or an open sea, endless and unknowable. It asked whether human beings, clinging to one planet, should measure their worth by their mastery of physics or by their willingness to wonder. The silence of the visitor was not only a scientific riddle, but also a philosophical one. If the universe speaks in mysteries, perhaps our task is not always to solve them, but to listen. In that listening lies humility. In that humility lies wisdom. And in that wisdom lies a different kind of knowledge, not of what the universe is, but of what it means to be alive within it. There is a danger in ignorance, and with 3I divided by Atlas, that danger was felt most sharply not in the object itself, but in what it revealed about humanity's limits. The visitor posed no direct threat. Its trajectory carried it safely past Earth, destined to vanish once more into interstellar night. And yet, its refusal to be fully understood became a different kind of peril, the peril of blindness. For centuries, civilizations have confronted the unknown with caution. A failure to interpret the signs of the heavens once meant famine, as eclipses and comets were misread as omens. Today, ignorance carries new stakes. In a cosmos where fragments from distant systems can arrive unannounced, the inability to understand them leaves humanity vulnerable not to superstition, but to miscalculation. What if one day a body like 3I divided by Atlas were massive, unpredictable, and on a collision path? To meet such a visitor without understanding would be to face catastrophe unprepared. This was the quiet fear beneath the debates. It was not that 3I divided by Atlas itself would destroy us, but that its mystery exposed the fragility of our predictive power. If an object so small could confound the best telescopes, the most refined instruments, and the sharpest minds, then what other forces, still unseen, might lie beyond our readiness? The danger of ignorance is not only in what we do not know, but in what we cannot anticipate. And ignorance does not stay confined to science. It shapes imagination, and imagination shapes fear. Journalists whispered about alien probes, while scientists worked to silence the noise. But in that very act of silencing, the possibility gained strength. To deny too quickly is to plant seeds of mistrust. To remain silent is to invite speculation. Thus, ignorance became fertile ground for both wonder and dread. Some thinkers argued that this was not a weakness but a gift. Ignorance, they claimed, is the engine of science, the spark that drives inquiry. Without mysteries, there would be no progress. And yet, when the mystery feels too large, too unyielding, progress falters and fear creeps in. The balance between inspiration and paralysis is delicate. 3. I, divided by Atlas, balanced upon it like a blade. The fear of ignorance grew deeper still when framed against humanity's place in the cosmos. Our species has mastered only a single planet, reached only a handful of nearby worlds with probes, and built instruments that see only fractions of the universe. Against such limits, the arrival of something that refuses explanation feels like a rebuke. It reminds us that we are still children at the edge of a forest, peering inward with lanterns too dim to reveal the whole. And so, the danger of ignorance is not only practical, but existential. It reminds us of how easily we mistake understanding for mastery, how thin our knowledge truly is compared to the abyss. 3. I, divided by Atlas, in its silence, became not only an astronomical puzzle but also a lesson that the greatest peril may lie not in what we discover, but in what passes us by unnoticed, uncomprehended, and unresolved. Though 3I divided by Atlas slipped harmlessly through the solar system, the thought that lingered was not about what it had done, but about what it implied. Its very presence raised the possibility of recurrence. If one interstellar object can wander through our skies, and then another, and then a third, what is to stop countless others from following? The question was no longer whether we would see another, but when and what form it might take. Astronomers began to imagine futures crowded with such visitors. Perhaps the galaxy is filled with wandering debris, ejected during the births and deaths of planetary systems. Perhaps Oumuamua, Borisov, and Atlas were not rare exceptions, but the first few raindrops before the storm, hints of a constant traffic of interstellar fragments crossing invisible borders. If so, then humanity is not an observer of isolated miracles, but a resident of a crossroads, where the pathways of stars intersect in silence. This thought brought both awe and unease. Awe because it suggested that each new visitor might carry secrets of worlds beyond reach, fragments of alien chemistry, stories written in their scars. Unease because not all visitors will be harmless. A larger body, dark and fast, could one day arrive on a trajectory less forgiving. The memory of Earth's ancient impacts, the craters, the extinctions remains etched in geology. To imagine an interstellar body of sufficient mass colliding with Earth is to imagine catastrophe on a scale beyond comprehension. Beyond the danger lay another question. What if the next visitor is stranger still? 3. I, divided by Atlas, already resisted categories, already carried the weight of anomaly. If the next carries new contradictions, new spectral silences, new gravitational riddles, then the pattern deepens. With each unexplained arrival, the possibility grows that these objects are not mere rocks, but something else entirely, fragments of processes or even designs we have yet to imagine. For NASA, this possibility has already shaped action. New survey telescopes are being planned and constructed, instruments designed to scan the sky with greater speed and sensitivity, to catch such objects before they slip away. Yet, even with vigilance, there remains a limit. These visitors come unannounced, uninvited, and they depart quickly. To intercept one, to send a probe, would require readiness on a scale humanity has not yet achieved. The thought that 3I divided by Atlas may not be the last is both a challenge and a warning. We may not be prepared when the next arrives. And still, in the quiet reflections of those who watch the stars, the question takes on a philosophical weight. What if these visitors are not random? What if the cosmos sends them with rhythm, with purpose, with meaning we cannot yet decipher? To ask such questions is to step beyond science into myth, but myth has always lurked in the shadows of astronomy. A sky filled with strangers is a sky filled with stories, and every story carries both wonder and fear. 3I divided by Atlas was not the end of the mystery. It was the beginning of a realization that the solar system is not isolated, not sheltered, not immune. We are open to the galaxy, and the galaxy does not move in silence. Visitors will return. Some may clarify, some may terrify. And in their passing, humanity will continue to measure itself against the unknown. When astronomers reflected on the passage of 3I divided by Atlas, they found themselves confronting not only its peculiarities but also the vast scale that made it possible. For an object to travel from one star system to another requires time measured not in centuries but in millions of years. To cross such gulfs demands patience beyond comprehension and endurance beyond imagination. Against that immensity, humanity's efforts appeared small, almost fragile. The challenge of scale was written into every calculation. The solar system itself, so immense to us, is but a grain of dust in the galaxy. Light takes hours to move from the sun to its distant planets, yet even at the speed of light, it would take tens of thousands of years to cross the Milky Way. And here was 3I divided by Atlas, a fragment that had done precisely that, not in a single lifetime, not in 1,000, but across epochs that erase civilizations like waves erasing footprints in sand. This scale diminishes human endeavor. Our spacecraft crawl at tens of kilometers per second. 3I divided by Atlas raced faster still, indifferent to our slowness. The Voyagers, humanity's farthest probes, have only just stepped into interstellar space, and even they will wander for millennia before approaching another star. Meanwhile, fragments like Atlas drift freely, effortlessly, carrying the legacy of their origins without engines, without intention, without haste. The philosophical weight of this contrast is heavy. Humanity measures time in days and years. The cosmos measures it in ages. We see history as centuries. The universe sees it as instants. To stand beneath the stars is to confront this dissonance, and to watch an interstellar visitor glide across the sky is to feel it in the marrow. We are small, our time brief, our reach narrow. Yet, there is also a strange comfort in this realization. If 3I divided by Atlas can endure millions of years of wandering, then perhaps the universe itself carries memory. Perhaps fragments like this are records of stories long vanished, testimonies to collisions, creations, and destructions we will never see. Their scale is not only vast but narrative. They are the archives of the cosmos, drifting libraries written in stone and ice. Still, the challenge remains. How can humanity, so small, hope to comprehend or engage with such immensity? Our telescopes capture only glimpses. Our theories stumble against anomalies. Even our language strains, reaching for metaphors of oceans, deserts, and shadows to describe what scale denies. The presence of 3I divided by Atlas did not shrink this gap. It widened it, reminding us that the cosmos is not proportioned for our comprehension. The fear embedded in this scale is subtle but profound. If we are so small, then what else moves unseen across the galaxy? If we are so brief, then what dramas unfold while we sleep? The arrival of 3I divided by Atlas was not merely an astronomical event, it was a confrontation with scale itself, a reminder that to exist as humans is to live on the smallest rung of cosmic immensity. And yet, paradoxically, that very smallness makes our awareness all the more remarkable. To measure an interstellar visitor, to name it, to record its fleeting presence, this is humanity's defiance against scale. We may be tiny, but we are awake. And, in being awake, we claim a place in the story, however brief. The enigma of 3I divided by Atlas revealed something more than anomalies in data. It exposed the way science itself responds to the unknown. For each mystery it carried, scientists reached for sharper instruments, deeper calculations, and more daring hypotheses. In doing so, they tested not only their theories, but their very method of knowing. This became the test of science. Could our tools, designed for the familiar, rise to meet the unfamiliar? Astronomy has always thrived on patience and humility. From the first maps of the heavens drawn on clay tablets to modern arrays of space telescopes, it is built on the discipline of watching carefully, over long periods of time, and assembling truth from faint signals. But interstellar visitors stretch that discipline to its breaking point. They do not linger, they do not return, they pass quickly, offering only a brief window before they vanish forever. To study them is to fight against time itself. With 3I divided by Atlas, the struggle was evident. Observatories worldwide coordinated, pooling data to catch the faintest variations in brightness and motion. Analysts refined orbital models with unprecedented care, searching for the smallest deviations. Theories proliferated, some cautious, others bold, each tested against the meager fragments of evidence. This global effort revealed science at its most vulnerable and its most noble. Vulnerable because the data was never enough, noble because inquiry pressed forward anyway. The lesson was clear. Science is not the possession of certainty, but the pursuit of it. The very strangeness of 3I divided by Atlas forced scientists to expand their imagination, to link cosmology with particle physics, to weave together astronomy, philosophy, and speculation. Doubt became not a weakness, but a tool, sharpening the questions and driving the search for better answers. At times, frustration crept in. If even the combined might of Hubble, JWST, and Earth's greatest observatories could not pin down the nature of a single fragment, what hope was there for the countless mysteries still hidden in the dark? Yet here, too, lay the essence of science. Progress comes not in the conquest of every question, but in the widening of inquiry. Each anomaly opens new doors. Each failure to explain marks the edge of future discovery. The test of science, then, was not whether 3I divided by Atlas could be fully explained. It was whether the community could face the unknown without retreating into denial or superstition. By confronting the mystery with honesty, acknowledging gaps, resisting premature closure, science proved itself resilient. The visitor may have left unanswered questions, but it also left a legacy of strengthened methods, sharpened awareness, and deeper humility. In this sense, 3I divided by Atlas was less a riddle to be solved than a mirror held up to science itself. It showed us the limits of our instruments, the resilience of our curiosity, and the courage required to dwell in uncertainty. The object passed, but the test remains, echoing in every telescope still turned toward the night. As 3I divided by Atlas receded into the darkness, its scientific puzzles gave way to something more intimate, reflection on the fears it awakened. The visitor itself was silent, harmless, passing without collision or disruption. Yet within its mystery, humanity found a mirror of its own vulnerability. What we fear most is often not the object itself, but what it reveals about us. For centuries, people have looked to the sky with equal measures of awe and dread. Comets once inspired terror, believed to foretell the fall of kings and the ruin of empires. Meteors were seen as arrows from gods, celestial warnings hurled into human affairs. In the age of reason, those fears were quieted by mathematics. Orbits replaced omens, physics replaced prophecy. Yet the arrival of 3i divided by Atlas stirred something older, more primal. It reminded us that the unknown still has the power to disturb, not because it threatens directly, but because it exposes how fragile our knowledge truly island. The mirror of fear it carried was subtle but profound. It reflected the fragility of human security, the knowledge that the solar system is not sealed, that objects from the void can intrude at any moment. It reflected our intellectual vulnerability, the realization that even with the most advanced instruments, we could not decipher a single visitor completely. And it reflected existential fragility, the suspicion that our place in the cosmos is smaller, weaker, and more precarious than we admit. Some interpreted the mirror differently. Fear, after all, is not only paralysis, it can also be illumination. To be unsettled is to be awakened. If 3i divided by Atlas reflected humanity's vulnerability, it also reflected the possibility of growth. In confronting the unknown, we learn humility. In grappling with anomalies, we sharpen our tools. Fear becomes the shadow that outlines wonder, the darkness that gives meaning to light. Yet the unease could not be dismissed. In whispered conversations, scientists admitted that the object had shaken them not because they believed it to be a threat, but because it reminded them how easily certainty collapses. Humanity prides itself on knowledge, on mastery of physics and technology. But here was a fragment of stone and silence, smaller than a mountain, that defied classification. If something so small could unravel our models, what of the greater mysteries that still roam the galaxy unseen? In this sense, 3i divided by Atlas was less an intruder than a teacher. Its lesson was not in what it was, but in what it revealed of us. That fear arises not from danger, but from meaning, not from impact, but from implication. The mirror it held up showed humanity its fragility, but also its courage. To feel fear and still pursue understanding is the essence of science. To tremble before the unknown and still reach outward is the essence of being human. When the fear subsided, what remained was something older, gentler, and perhaps more enduring: wonder. For all its silence, for all its refusal to be categorized, 3i divided by Atlas reminded humanity of the strangeness of existence itself. Awe and mystery are not intrusions upon science, they are its lifeblood. Without them, observation is empty, numbers are sterile. With them, even the faintest flicker of light across a telescope sensor becomes a doorway to meaning. The persistence of wonder rose from the very same qualities that had provoked unease. Its silence was unsettling, yes, but it was also beautiful. To imagine a fragment drifting across the galaxy for millions of years, untouched and unobserved until this single fleeting moment, is to imagine endurance beyond measure. Its anomalies, though frustrating, were also gifts. Reminders that the universe is not a finished book, but an unfinished poem, its verses written in riddles we are still learning to read. Scientists often speak in terms of data, yet many admit quietly that what sustains them is not certainty, but awe. To glimpse an interstellar visitor is to glimpse the unimaginable, a shard of another sun's story, a relic of a distant world, a messenger that has crossed the gulfs between stars. In its passage, 3i divided by Atlas carried no words, no tale, no broadcast. Yet its silence was eloquent. It whispered, that the universe is larger than we can fathom, stranger than we can model, and richer than we can ever exhaust. The public, too, felt this wonder. Headlines spoke of alien probes, of cosmic riddles, of mysteries unsolved. Behind the noise lay something simpler, the joy of being alive in a moment when such things can be witnessed. For most of human history, the stars were unreachable, eternal, beyond touch. Now, fragments from those stars enter our skies, and we have the instruments to see them. To live in such a time is to live in a rare age of awakening. The persistence of wonder is what balances fear. Fear tells us how small we are. Wonder reminds us that smallness can still contain meaning. Fear shows us the abyss. Wonder shows us the beauty of gazing into it. In the story of 3i divided by Atlas, both emotions are inseparable, twined together like shadow and light. As it retreated into darkness, becoming fainter with each passing week, scientists knew they would likely never solve its riddle. But perhaps that was not failure. Perhaps the true gift of 3i divided by Atlas was not explanation but experience, the reminder that to encounter the unknown is itself a privilege, a moment of intimacy with the cosmos. The visitor may be gone, but the wonder it left persists, glowing quietly in the human heart. And then, almost as quietly as it had arrived, 3i divided by Atlas began to fade. Its path carried it away from the sun, away from Earth, back into the deep cold from which it had come. Telescopes strained to follow its dimming glimmer, but night by night it slipped further into obscurity. Soon it would be gone, indistinguishable from the background of stars, leaving behind only records, numbers, and the memories of those who had watched it. The silence of space reclaimed it. There was no final revelation, no sudden burst of clarity, no comet's tail ignited to explain its nature, no unmistakable spectral signature appeared. It simply departed, as though indifferent to the questions it left behind. In this, 3i divided by Atlas resembled Oumuamua. Both had passed through the solar system like ghosts, unbound, silent, vanishing before certainty could catch them. The departure carried with it a peculiar ache. For scientists, there is comfort in repetition, in the ability to observe again and again until doubt gives way to clarity. But an interstellar visitor does not allow that luxury. It passes once. Its secrets must be gathered in the brief interval of its appearance, and whatever is missed is lost forever. 3i divided by Atlas departed with its mysteries intact, carrying them outward into the abyss where human instruments cannot follow. And yet, there was something profound in its vanishing. The silence it left behind was not emptiness but echo. Every unanswered question, every fragment of data, became a seed for future inquiry. The very absence of closure became its own kind of message, that the universe does not exist to satisfy human curiosity. It exists in its own vast rhythm, offering glimpses but never guarantees. The silence of space, then, was not defeat but reminder that even in an age of satellites and space telescopes, the cosmos retains the power to withhold, that science, for all its progress, remains a dialogue with a partner who often refuses to reply, and that sometimes the most important truth is not what is revealed, but what is left unresolved. As 3i divided by Atlas disappeared into the dark, the astronomers who had studied it knew they would likely never see it again. It would drift on for millions of years, perhaps brushing past other stars, perhaps wandering endlessly through the interstellar void. Its story with humanity was brief, but its silence will linger. For in that silence lies a reminder that the cosmos is vast, patient, and inexhaustible, and that every mystery is also an invitation to keep looking upward. When at last the object was gone, the night sky felt subtly altered, not because anything had changed in its stars, but because something had passed through something that had forced humanity to reckon with its place in the cosmos. 3I divided by Atlas was no larger than a mountain, no brighter than a faint glimmer of light, yet it carried with it the power to unsettle entire frameworks of thought. Its lingering shadow was not cast across space, but across the human mind. In classrooms and conference halls, scientists continued to speak of it in cautious tones. They debated models, revised papers, traced its trajectory again and again, as though one more calculation might unlock its secret. But in quiet moments, away from equations, the reflection deepened. What does it mean that something can come from the dark, glide through our system, and leave us with more questions than answers? What does it mean to be so small in a universe so endlessly strange? Philosophers took the baton from astronomers, reminding us that the cosmos is not only a field of study, but a mirror of existence. If fragments like 3I divided by Atlas can cross interstellar gulfs, then so too must humility cross the boundaries of human ambition. The mystery it carried was not only scientific but existential. It reminded us that reality does not revolve around us, that meaning is not guaranteed, that knowledge is always provisional. Yet in this humility lay an unexpected gift. 3I divided by Atlas revealed the fragility of our understanding, yes, but it also revealed the resilience of our wonder. Fear and awe were intertwined in its passing, but both pointed to the same truth. We are awake in a universe that will never cease to surprise us. To witness an interstellar traveler, even in silence, is to be reminded that we live not in isolation but in connection, that the stars are not distant abstractions but neighbors whose stories sometimes drift into our own. The lingering shadow of 3I divided by Atlas is therefore not one of despair but of depth. It reminds us that science is not about closing mysteries but about living with them, walking along their edges and allowing them to enlarge our sense of being. The object itself has gone, its light lost in the abyss, but the questions remain alive, vibrant, urgent. They are the true inheritance of its visit. In the end, perhaps this is the role of such visitors, not to answer, but to ask. To remind humanity that the cosmos is vast beyond reckoning, and that within its vastness we are both insignificant and extraordinary tiny creatures able to notice, to wonder, to fear, and to dream. 3I divided by Atlas has left, but its shadow lingers, a quiet echo that will follow us as long as we look toward the stars. And now, as the visitor recedes beyond sight, the pace of thought slows. The questions remain, but their sharp edges soften. Imagine the object fading into the velvet dark, becoming one with the countless unseen wanderers that drift between stars. Its silence is no longer unsettling but gentle, like a door closing softly at the end of a long night. In this quiet, the fear dissolves into calm. The universe has always been larger than our comprehension, always filled with riddles that slip beyond reach. To dwell on them endlessly is to exhaust the spirit, but to acknowledge them, to let them be, is to find peace in mystery. 3I divided by Atlas has come and gone, and still the stars shine, still the earth turns, still life continues in its fragile, beautiful rhythm. Perhaps that is the final lesson, that we are not meant to master the cosmos, but to share in its wonder, to look up and see not answers, but invitations. Each anomaly, each silence, is part of a conversation that stretches across time, a dialogue where our role is not only to measure, but also to marvel. So let the shadow of 3I divided by Atlas fade into the vastness, leaving behind the quiet gift of perspective. Let its mystery remind us that the unknown is not a threat, but a companion, always present, always guiding us toward deeper humility. And as the night settles, let that humility become comfort. For in the end, the universe does not need to reveal its secrets all at once. It only needs to remind us, now and then, that we are part of its story, and that story is still unfolding. Sweet dreams.